In this video, we'll look at converting rectangular equations into polar equations. Remember, we want to remove any x's and y's and end up with just r's and thetas. We have these familiar substitutions that we can make to help us in that process. Up first, we're looking at y equals 3. Now, if you think about what that looks like in the rectangular coordinate system, that's just the horizontal line at y equals 3. But we want to convert it to polar. We right away have a substitution that we can make. Y is r sine theta. So r sine theta will make that substitution and replace in the place of y, r sine theta equals 3. Now this is perfectly okay. We have removed x's and y's, and we're in terms of just r's and thetas. But sometimes, depending on the directions, depending on the assignment, your instructor, whatever, sometimes we may need to solve for r. So let's assume we do want to take it a step further and isolate r. In order to do that, we need to divide both sides by sine. Now we are assuming in that case that sine is not 0. So if we divide both sides by sine, we'll get r equals 3 divided by sine theta. We could then rewrite that as, r equals 3 times 1 divided by sine theta. And we know that 1 divided by sine theta is really cosecant theta. So again, this is just an alternate way to write it if we wanted to solve for r. Again, we are having to assume that sine theta is not equal to 0. We don't want to divide by 0. In example B, we can start by making some substitutions. We know that y squared we can replace with r sine theta. That is your y, and then we need to make sure it is squared, and we will make a substitution for x. X we know is r cosine theta. On the left, we can square both of those factors. We'll have r squared sine squared theta equals 3r cosine theta. And from here, let's set that equal to 0 to clean it up a little bit. R squared sine squared theta minus 3r cosine theta equals 0. Notice we have simplified a bit. We no longer have x's and y's in the equation. The equation is only in terms of r's and thetas. So again, that is perfectly acceptable. However, sometimes the directions on the homework, quiz, lab, test, whatever, or maybe your instructor wants you to solve for r. So let's see if we can do that. Going back to this statement, let's say we divided this statement by r. Let's divide by r on the left and the right. On the left, if we divide by r, we'll get r sine squared theta. And on the right side, if we divide by r, we'll get 3 cosine theta. Again, trying to isolate r, we would then divide by sine squared theta. Again, assuming sine theta is not 0, we'll get 3 cosine theta divided by sine squared theta. We can simplify that a bit. Let's write that as 3 cosine theta divided by sine theta times 1 divided by sine theta. And then that would give us, I'm running out of space, that would be r equals cosine theta divided by sine theta is cotangent theta, and then 1 divided by sine theta is cosecant theta. So again, just an alternate way to write that equation with r being isolated. We did have to make some assumptions that sine theta is not 0.